All right, guys, we're back and we're going to be looking at solving quadratics by graphing. So we're going to look at what that means on the coordinate grid when we have a quadratic graph. So remember that we had zeros was also the x-intercepts. And so that is, if you remember, that's when y is basically 0. So if I have a coordinate point, x comma y, when I write an x-intercept, it's the x value, and then y is 0. So if you'll notice here, if I were to replace 0 in my standard form with y, this would be a function, y equals ax squared plus bx plus c. And so you can see that that's where y is equal to 0. So zeros, x-intercepts, are also called the solutions because obviously that's where they're graphed on the coordinate grid. And then also they are called roots. So we kind of talked about that a little bit within the GIM kit when we looked at the different roots. So we still have our standard form, ax squared plus bx plus c is equal to 0. We're just going to replace that 0 then with a y. Make sure everything is on one side, and then we'll find those x-intercepts or even zeros, and that's basically what it calls it. So let's take a look at just these graphing points here. So if I have these two functions, so have it graphed here, you can see that my solutions, roots, x-intercepts, all the same thing where it crosses the x-axis, which we have one right here and one right here. So the solution to this function here is going to be x equals -7 and x equals -3, those two solutions. Okay, so those will be the solutions based on that graph there. Now, this one is a little bit tricky because you'll notice here it doesn't ever cross the x-axis. It's never going to ever cross the x-axis because it comes down to a low point here, which is above the x-axis, and it's going to keep going up. So something like this is going to have no real roots, is what we would say here. Okay, so if it doesn't ever cross the x-axis, so anytime you have a quadratic equation, you could plug it in and look to see, are there going to be two solutions? Are going to be one solution? No solutions, no real roots. The reason why I have to put that in there, the real part, is because you could have imaginary roots. We're not going to get into that, and so you don't have to worry about that, but just know that it will say no real roots. So that was just kind of a little tricky one there. All right, so here's this last one, and we are going to plug this in the calculator. So I'm going to show you how you can do this on the calculator. All right, so we're going to look at finding the zeros for our function here. So what we're going to do is we are going to come over here, and I'm going to go home and add a new document over here. And then I'm going to add a graph. So I have f1 of x, so that's what we're going to plug this in. So we're going to have 2x squared minus 16x. I would highly encourage you to follow along with me in this, plus 24. And then I'm going to hit enter. So you can see our graph here. We can't see our vertex, but that's okay because we don't need to see our vertex. We need to see where it crosses the x-axis here. So it looks like you can see that it looks like it's going right on top of it. So here's what I'm going to do. If you'll use your little mouse pad, so you can use this as a little mouse pad here. And I want you to come over here, and you see how it looks like a little grabber deal. If you'll hit Control and the center button, it's going to grab that. It's going to pinch it. I'm going to move over here because I don't even want to see that. Okay. I'm going to make sure I can see this really well. It looks like it's going directly through 2 and 6. But I'm not quite sure. It could be 2.01. So don't ever just count over and just say, oh, that's what it is. If you'll go to Menu and go down to Analyze Graph, and then it's going to say 0. So we're going to have the boundary part just like we did with a vertex. So what you want to do is you want to use your little mouse pad over here, and you're going to select this over. I'm going to hit that center button right in the middle of the mouse pad, and then I'm going to drag it over. I'm not going to include both of them. I'm just going to include 1 0. And it tells me that I do have a 0 at 2, 0. Then I'm going to hit menu again and go down to analyze graph, which is 6. Let's see here. And I do want it to go over to 0 again, and I'm going to make sure that the other 0 is in the shaded region. And then it tells me that the other 0 is 6, 0. So that's how you would put that in your calculator. So you're going to plug it in, plug your function in, then you're going to hit menu, analyze graph, and then you're going to type in 0. The main thing is that you put the one of each of these in the little shaded region. And so those are our 2 solutions. All right, so when we graph this, you can see that we had a 0 at 2, 0 and at 6, 0. So what does this mean as far as solving it and writing this as an assistant or writing this as actual solutions? So if we had that equal to 0, f of x or y is equal to 0, so that's why we're finding those zeros, we would have x is equal to 2 and x is equal to 6. So they both cross there. So lots of different ways to represent those zeros part. You can write them as solutions here. Okay, you can write them as zeros, which I would probably still write x equals 2 and x equals 6. So that's a 0. There's another vocab thing. Roots you would talk about here. And then x-intercepts would be the only way probably the only time I would say you would need to be able to write that as an ordered pair. So you want to keep track of that. I just saw lots of people kind of get that kind of confused on what that meant. So solving quadratics by graphing. So we can have solving quadratics by factoring. You can solve quadratics by using the quadratic formula, or you can solve quadratics by graphing on your graphing calculator and finding the zeros.